All right, AP Calc. We're going to be going over the limit definition of a derivative today, which we have briefly covered, but we're doing some new types of questions with this in today's lesson. So I don't know if you guys remember or not, but we got this, or came up with this formula towards the beginning of Unit 2. And then we went into quite a while where we were trying not to use this, right? That was the whole goal, was we don't want to use this. We want to just basically bypass this formula by memorizing all of our different derivative rules, like the power rule, the product rule, quotient rule, all that stuff. But now we're kind of circling back to this and saying, okay, this is a definition of a derivative. So here's what we need to be able to realize. When something's in this form, it's just asking us to take a derivative of potentially what's right here, or maybe what's right here without the h in it. All right, so that would be just the derivative of the function. If there's values plugged in for these x's, the problem is telling us we've got to take a derivative of the function and then plug in a number. So let's look at what one of these examples might look like. So we've got the limit as h approaches 0 of e to the x plus h minus e to the x all over h. Now, I'm going to just copy and paste the formula. Let me erase a little bit. So I want to just kind of copy this over to the next slide so we can see them right next to each other. That will work. Let's try again. There we go. All right, so this is our definition of a derivative. And so I just want you guys to see, hey, there's h on the bottom. H is approaching 0. We have an x plus h and an e to the x. So the first step of these questions is just recognizing, hey, this is the limit definition of a derivative. Now what we need to do, let me get rid of the formula. Now what we need to do is identify what f of x is. Well, there's potentially two places you can look at where f of x is. It's either after the minus, but sometimes it's not going to work to look there. So we're going to have to look at before the minus without the h. All right, so either way, f of x is just e to the x. Now, because this is a limit definition question, all right, it wants us to take a derivative of this function, which the derivative of e to the x is just e to the x. And so that's our answer. I know it seems like a lot of weirdness for just that, which was here and here, but that's how we would do one like this. It's identifying f of x and then realizing the problem wants us to just take a derivative here. So let's look at another one here. So we've got the limit as h approaches 0, and it's all over h. And so this, again, is our clue that we're using the limit definition of a derivative. All right. Now, what I want to do is I see there's a 2 here and here. I'm just going to temporarily pretend those are x's just to show you guys something. So this was an x, but really it was a 2. All right. So first, I want to identify what the function is. And again, I can look two places to see that. I can look at after the minus, and I see the natural log of x, or I could look at in front, and if I ignore the h, our function is the natural log of x. So what we have to recognize here is, again, this is the definition of a derivative, so we need to take a derivative here. So we're going to find f prime. The derivative of the natural log of x is 1 over x. Now, we would be done at this point, but that's what those 2's were telling us at the beginning, that we are supposed to take a derivative and plug in 2. All right, and so I want us to first take the derivative of the function. All right, we have our derivative. Now we can plug in 2. F prime of 2 is just 1/2. All right, one more. Same thing. We've got the limit as h goes to 0. We've got h. And so this problem is asking us for f prime. And because there's no x in here, x comes before h. And so this is asking for f prime of 2. That's our question, f prime of 2. To figure out f prime of 2, we first need f prime of x. And before that, we need f of x. F of x. So this one is not as obvious to figure out what f of x was. Like on the last couple, f of x was there if we just replaced 2 with x. F of x was here if we replaced 2 with x and ignored the h. And we could also look at 2 places on this one. But here, there's a number at the end, and so I can't look here to figure out what f of x is. It's not going to help us. All right, what we're going to do is, again, pretend that 2 was just an x, because it's in front of h. Whatever's in front of h is always x. Now, because h is going to 0, we're going to ignore h. That tells us our function is just x to the 4th. That's what f of x is here, x to the 4th. And that's the most difficult part of this question, is just identifying what f of x is. Now we know we have to take a derivative. So the derivative of x to the 4th is 4x to the 3rd. And now we plug in our 2, and we follow order of operations. So make sure you're doing the exponent first before you multiply. All right, 2 to the 3rd, 2 times 2 times 2, that gives us 8. And 4 times 8 is 32. All right, so that's our answer to this one. And again, what did I do with the 2? Well, again, I was pretending it was just an x. But I already knew we need to find f prime of 2, and that's why I plugged the 2 in for my x at the end here. All right, so these are kind of weird. It's really just recognizing what it wants us to do. But we'll practice. You guys will practice a little bit at home, and then we'll do some practice in class as well. And most students are able to get this. It just takes a little bit of time at first to kind of figure out what these questions are asking. All right, but that's it, guys. Stay flawless.